Hey folks, welcome back to another video. Today we're looking at question 1472, design browser history. The way we'll be approaching this problem is by using an array list and a pointer, like basically an integer that keeps a track of the index that we're currently at. There are many other ways to solve this problem. We could have easily used two stacks to be able to keep pushing and popping. But the thing is, we would have to maintain two stacks. Whenever we have to say like back, we'll have to like pop them and push them back. Seems a little complicated, but for our solution, since array list would give us like the same time complexity as two stacks, we can just go ahead with this. Awesome. So let's get started. The first thing that you need to do is to create the members of this class. So we need one list. So let's do that. And this will store strings, right? And we'll call this history. And then we have index, right? So once we have the members, let's initialize them within the constructor. History would be equal to, it would be a new array list. And then you would push the home page to the array list home page, and you would initialize the index to be 0. We don't really have to increment the index by 1 because we know all of the indices in data structure start with 0. Awesome. So for visit, what we need to do is we need to add a given URL string to us at the index that we're at, and we need to remove everything in front of that. So what we'll do is that there are cases where the index is already on the last index, as in like you don't have to remove everything, you just have to add the new URL. But if it is not, how do we check that? We check URL history. Dot size -1. If the last index is greater than the index that is currently given to us, what we need to do is we actually need to remove it. So it would be just keep removing everything at the last index. Right, so this keeps looping till the index is equal to URL history, and then what we need to do is just add the URL that's given to us. So it will be URL history dot add URL, and then you need to add the index, like just increment it by 1 because you've added it, and now the index would be incremented by 1. All right, so that should take care of the visit function. And for backwards, we've seen this in a couple of problems that we've solved before. So we basically check if current index minus steps, if it is less than 0, you would assign index to be equal to 0. So we need to take x steps back, so number of steps back, but if it is greater than the index that we're at, we just need to stop at 0. Else we just need to decrement steps by index by steps, and in the end you just need to return the given value at that index. Return history.get, and then you send back the index. So that should take care of the back function. Let's do the same for the forward function. So in this case, if since we're moving forward, we need to check if index plus steps is greater than or equal to URL history dot size. Then what we need to do is we need to set index to URL history dot size -1. Basically, you're setting it to the last index of the array that's given to us. If not, you just increment it and return the value that's stored in the index. So that should take care of all of the functions that we need to write. Let's try compiling this. All right, the first test case is okay. Everything else is okay as well. Okay, awesome. So let's talk about the space and time complexity of the entire solution. So there are 4 different functions here. So this would take off 1, this would take off n, since we are removing everything that we need to remove after. So this function's time complexity is of n. This would be of 1. Backwards, forward is also of 1. The space complexity of the solution is of n, since we are using a data structure right here to store the list of all of the URLs. Awesome, so that's the solution for this problem. If you have any questions, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I would really, really appreciate that. Thanks so much. I'll see you folks in the next video. Peace.